So here we are doing the thermodynamic questions. We are doing free response first. The aluminum metal can be recycled from scrap metal by melting the metal to evaporate impurities. A. Calculate the amount of heat needed to purify 1 mole of Al, originally at 298 K, by melting it. The melting point of Al is 933 K. The molar heat capacity of Al is 24 joule per mole K, and the heat of fusion of Al is 10.7 kilojoule per mole. So we know the temperature in change. The temperature in change is from 298 K to 933 K, which is 635 K, and we use the formula to find the Q. Q equals mc delta T, where m is 1 mole times the C is the molar heat capacity is 24 joule per mole K, and times 635 K, which is the temperature in change, and we got 15,000 joules, and we change it to 15 kilojoules. And in the question it says the heat of fusion of Al is 10.7 kilojoule per mole, which the heat of fusion is the energy required to change a gram of a substance from the solid to the liquid state without changing its temperature, and this energy breaks down the solid bonds but leaves a significant amount of energy associated with the intermolecular forces of the liquid state. So it means it takes 10.7 kilojoules to melt the Al at 933 K. So we need to add 15 kilojoules to 10.7 kilojoules, and we get 26 kilojoules in total. So the amount of heat is 26 kilojoules. And for part B, the equation for the overall process of extracting Al from Al2O3 is shown below, which requires less energy, recycling existing Al or extracting Al from Al2O3. And we have delta H equals 1675 kilojoules per mole. So for extracting Al, we calculate 1675 kilojoules per mole times 1 mole of the total reaction divided by 2 mole of Al. We got 837.5 kilojoules per mole of Al. It means producing 1 mole of Al from Al2O3 requires 837.5 kilojoules. Because 26 kilojoules is less than 837.5 kilojoules. So that means recycling requires less energy. And for the multiple choice part, the first one is given the following thermochemical data, and we need to determine the heat of the reaction 2NO plus O2. So first we switch the side of this reaction. We got 2NO2 equals 2NO plus O2, and we also need to change delta H to positive. We switch this side. So we have 2NO2 equals 2N2O4, and delta H has to be negative 57.93 kilojoules. And we already have 2NO plus O2 can be transformed to 2NO2, which delta H is negative 113.14. And we switch this side. Two and O2, and we have positive now, because we need to find 2NO plus the O2 transformed to N2O4. We need to wait. Yes, we use this formula to minus the transformed one, and we got 2NO plus O2, which is N2O4, and we got minus 113.14 kilojoules minus 57.93 kilojoules, and we got, let's see, we got negative 171.07 kilojoules. So we choose C for this one. And for the second multiple choice, which of the following can change the value of delta G for a chemical reaction? Because we already know that the formula is delta G equals delta H minus T delta S. So in this situation, we can only change the temperature to change the value of delta G for a chemical reaction. We choose D for this one. And for the last multiple choice, at what temperature is K equilibrium equals 1 if delta S equals 22.6 joule per K and delta H equals 15.3 kilojoules for a chemical reaction? Because KEQ equals 1, so that means delta G equals 0. And we use the formula delta G equals delta H minus T delta S. So we got T delta. The T is 404 Celsius. So we choose A for this one.